Tech Talks Education. Welcome back to confirmatory tests for cations. Specifically, we are looking at some cations that we can be asked to confirm using some reagents. And remember that sometimes you may not be given the reagent. So they will ask you to carry out a test of your own choice. That means choose a reagent, then you have to talk about how to carry out the test. Then you carry out the test, record your observation, and then deduce correctly about the ion that you have confirmed. So we have already looked at calcium ion and lead to ion. And with lead to ion specifically, look at the third test, that is the use of potassium iodide solution, which is a very common confirmatory reagent for testing or for confirming lead to ion. So let us go ahead and we look at others that we have still left. Let us look at zinc ion, which is part of our ZAP. We had already looked at this one here. So the confirmatory test for zinc ion. Let me maintain our table for test observation and deduction. And in this case, since we had already had a look at the equations for the reactions involved when we use the confirmatory reagent for confirming zinc ion earlier on, we are not going to write that equation again. So this is for our test. This column is for the observation. And this one is for our deduction. So here we go. So one of the reagents that we use is in this case, the reagent that we use is ammonia solution. So the procedure of the test is add the ammonia solution dropwise until in excess. This is for zinc ion, and we said that we're able to get a white precipitate, and the white precipitate is soluble in excess to form a colorless solution. And this one here means that we have zinc ion. Please take note that we had already seen what we call the reaction equations in this case, because we have the equation for the reaction when we have added just a few drops where we get a white precipitate, and then in excess whereby the white precipitate dissolves to form a colorless solution. So it is soluble in excess to form a colorless solution. And in that colorless solution, we saw the complex ion and also wrote the reaction equation earlier on. So this is how we can confirm zinc ion. It is a confirmatory test for zinc ion in solution. Mark Q. These ones are for these cations in solution only. Then let us go to the next one, and that is the ammonium ion. Ammonium ion in solution also. So let us also have that simple table for test observation and deduction as well, which you are not supposed to forget in this case. Test, observation, and then deduction. So for ammonium ion, we said that we can use sodium hydroxide solution in that we add sodium hydroxide solution dropwise until in excess, and then we heat the mixture, and we heat. You can say you heat or you heat the mixture. So we say that on adding sodium hydroxide solution dropwise until in excess, we simply get no observable change, but on heating, ammonia gas is produced. But we don't have to say that it is ammonia which has been produced. We need to talk about the characteristic properties of the ammonia gas that will make us to be able to identify it very easily. So, but on heating, ammonia is a colorless gas with a choking, colorless gas with a choking, irritating smell, and which turns moist red litmus paper to blue. So ammonia is the only common alkaline gas that we deal with here in qualitative analysis. So we deduce in this case that it is the gas which is ammonia that has been produced. Ammonia evolved. Therefore, we have ammonium ion in the solution under test. We are detecting these cations here in solutions. Mark Q or be able to remember this. Then let us also look at copper 2 ion with this formula of capital C small u 2 plus copper 2 ion. Let us also draw our simple table for test observation and then deduction. So our test in this case, testing for copper 2 ion in solution, we use also ammonia solution. So we need to add ammonia solution dropwise until in excess. So our distinct observation here is a pale blue precipitate soluble in excess to form a deep blue solution, soluble in excess to form a deep blue solution. And this one here is an indicator of the presence of copper 2 ions. So generally what we have seen here from Roman 1 up to Roman 5 are the cations whose confirmatory tests are very clear. So you don't have to forget these tests here because they are the confirmatory tests for these cations here. When you get these observations, then it means that the cation that you are testing for, you have confirmed it to be actually present. So you just write the name of that cation. Someone goes ahead and says ammonium ion is confirmed. There is no problem. It's okay. And even if you say that it is ammonium ion, it is also okay because it is there. So don't forget these confirmatory reagents for the cations. So in our next session, we shall be trying to see how we can distinguish between the cations using the reagents that we have already seen before we can go to the detection of anions. So Tech Talks Education, thank you for watching.